Hello there, Mr. Sutton here, bringing you the Pre-Cal Honors 8-2 Extra Practice Number 4 solutions on geometric series. In this one, we have a puzzle we have to solve, so let's go ahead and take a look at that. For this puzzle, we're trying to solve the riddle of what do you call spooky sausages? We have all these geometric sequence and series types of problems to solve, a lot of different types here, but for all of them, whenever you figure out the right answer, check it out and see if you can find it over in this column on the right. And whatever letter is next to your answer, put it over the problem number down in these blanks below. And it should hopefully spell out the answer to our riddle. So let's give it a go. For our first problem, we're trying to find the nth term if we have an a1 of 128, n of 9, and r of 1/2. So this one, I'm going to use my nth term formula. A to the n equals a sub 1 times r to the n minus 1. This is a good one for finding nth terms. And in terms of information that I need, I've got all the stuff I need. I have the a1, the r, and the n, so we'll just plug it all in and use the calculator. So we have a1 equaling 128, and then we have the r value of 1/2 raised to the power of 9 minus 1. And let's check that out on the calculator. So here's what I've entered on the calculator. If you want to know how to get this fancy fraction mode, on my grapher I just did alpha y equals, but you could use 1 divided by 2 division inside there as well. For the exponent, just make sure that you've got this whole 9 minus 1 in exponent land. If your calculator doesn't do the superscript kind of thing, you might need to use a parentheses around the 9 minus 1 to make sure it all gets counted as an exponent. So let's press enter on all this. And I got 1/2 or 0.5. Looking for that in my answer choices, I see I right there corresponds to 1/2. So we'll put an I over question number 1. For problem 2, they want the 6th term for the series beginning with 2/3, 4/3, and 8/3. So let's see, let me use my nth term formula, a1 times r to the n minus 1. And for my a1 this time around, I have the 2/3. They gave that to me as the first term of the series. Now for the r, what am I multiplying by each time to get the next term? You could take one term and divide it by the other, but it looks like we're multiplying by 2, because 2 times 2 is 4, and then the denominator would remain unchanged. So I have an r value of 2, n value of 6, so we'll do 6 minus 1. And I could use the calculator, but I feel like I should be able to do this without one. 6 minus 1 is 5. 2 to the 5th I know is 32. And then 32 times 2 gives me 64. So 64 thirds, final answer. And that is going to be L going in spot 2. For number 3, they just want the common ratio for this series here. So common ratio is just what you're multiplying by each time to get the next term in a geometric sequence. So you can just take any term and divide it by the term preceding it, and that'll give you your common ratio. So just to make my life easier, I'm going to go with just a2 divided by a1, so negative 8 over 2. But I could have done this with 32 over negative 8 or negative 128 over 32. Any of them should give me the same result, which in this case is negative 4. So negative 4 corresponds with E, so that's going to be 3. For this next problem, they just want the first 3 terms given an a sub 1 of 20 and an r of negative 3. So to get the next term in any geometric sequence, you just have to keep multiplying by the same number. So in this case, we're just multiplying by negative 3 over and over again. They gave us the first term already. That was 20. 20 times negative 3 is negative 60, and negative 60 times negative 3 should be positive 180. So 20, negative 60, and 180 is right there. That's another L going in spot number 4, right next to the first L. After those last 2 problems, you might be thinking, wow, this puzzle is going to be a piece of cake, but they did complicate things a little bit. They're asking us now to find the missing terms in this sequence. We've got 8, 2 numbers that we don't know, and then 27. This is already looking like it's going to be a little bit tricky because 8 and 27 don't have an easy to spot common base. There isn't a number I can think of off the top of my head that I could multiply it and get a 27 out of it if I started with an 8. So we're going to have to dig a little deeper. What we're going to need for this is the common ratio, the R value, and then we can use that on 8 to generate the next couple terms. So to get the common ratio, I'm going to go back to my nth term formula, a sub n equals a1 times r to the n minus 1, because I feel like I've got most of what I need for this formula except for the r value. So for my a sub n, I'm going to use 27 for that, so the fourth term. And then for a sub 1, that's the first term, that's 8. For the r, I'm going to leave that as an r because that's what we're looking for before we can get these other terms. And for the n, 27 was the fourth term, so I'm going to put 4 in for n, so 4 minus 1 for the exponent. Next up, I'm going to isolate this exponential term here. So I'll do that by dividing both sides by 8. That gives me 27 over 8 on the left side. And on the right side, this is just, let me simplify this to r cubed. All right, well, if r cubed is 27 over 8, that means to get r, I need to take the cube root. So when you cube root a fraction, you're cube rooting the top and the bottom individually. This is when you take any root of a fraction. So the cube root of 27 is 3. 3 cubed is 27. Cube root of 8 is 2. 2 cubed is 8. So this is going to be 3 over 2 for my r value. Now that I've got that, I'm just going to keep multiplying by 3 halves, starting with 8 times 3 halves, to get these next two terms. So 8 times 3 halves, I'm going to divide by 2 and multiply by 3 to complete that operation. 8 divided by 2 is 4. 4 times 3 gives me 12. So there's one answer. And then 12 divided by 2 is 6. 6 times 3 gives me 18. So there's my next one. And just to double check, 18 divided by 2 would be 9. 9 times 3, 27. So 12 and 18 is what I'm looking for. I've got that with choice W right here. So let me put a W in spot 5. For the next 5 problems, they're going to be asking us to find the sum given various pieces of information. So for this one, we have a first term of 64, common ratio of 3 halves, and we have 4 terms in the series. So let me just use my nth sum formula. Sn equals a1 times 1 minus r to the n over 1 minus r. So for this one, I have a a1 value of 64. So we're doing the sum of 4 terms, so S4. So we have 64 up there for a1. 1 minus the r is 3 halves. And the n value they gave us as well was 4. Next up, I have 1 minus r on the bottom, so that's 1 minus 3 halves. Tempting as it is, I'm not going to do this one in my head. I'm going to use the calculator, so let me do that. Let me enter all this off camera. So here's what I've entered on my calculator. And again, I make very generous use of the fancy fraction mode on here, alpha y equals and then n over d, to get all these nested fractions, because I really don't feel like trying to do this with a bunch of parentheses. The other nice thing about this fraction mode is that when you press enter on all this, it will, if possible, give you an answer that's a reduced fraction instead of a decimal. In this case, I didn't need that. I got 520 out of all this, but on other problems it might be useful. So 520, that matches up with E right there, so 6 is E. For this next one, I'm again finding a sum, and it looks like I've got some of the information I need. So here's my formula for my summation. We have a1, 1 minus r to the n, 1 minus r. I've got the a1, I've got the r, so that's good, but I don't know what n is. I know that the nth term, the last term of this series that I'm adding together, is negative 54, but I don't know how many terms there actually are in this series. So to get that, I'm actually going to use my nth term formula, a sub n equals a1 times r to the n minus 1. And I'm going to see if I can work backwards using this formula to figure out the nth term, or the number of terms here, n. So plugging things in here, I'll use negative 54 for a sub n. a1 is going to be negative 2. r they gave us was 3. And then I'll just leave n minus 1 as the exponent. Next up, I'm going to get my exponential term by itself. So I'll divide both sides by negative 2. Negative 54 over negative 2 gives me 27. So I have 27 equaling 3 to the n minus 1. And if you haven't solved one of these equations before, one way you could do this if you know about it is logarithms. And if you're taking a pre-calculus course, you may have encountered those already. But if you haven't, here's a trick you can sometimes use. If you can at least get both sides of this equation to be the same base to some power, you can use that as a little trick for getting these n's out of exponent land. So this 27, for example, I could rewrite this as 3 to a power, 3 to the third power. If I have 3 to the third equals 3 to the n minus 1, well, if the bases are the same and these things are equal, that means the exponents must also be the same. So I can actually rewrite this as 3 equals n minus 1, because otherwise there wouldn't be an equal sign here. And if 3 equals n minus 1, I can simply just add 1 to the other side to get 4. So there's my n value. That was a little bit of a journey, and I'm not even done yet. I still need to actually plug this back in with my a1 and my r to get my sum. But the rest of this is just plug-in calculator kind of stuff. So we have the sum of, in this case, 4 terms, so s sub 4. I guess I'll leave it as n, whatever, equals, we have our first term of negative 2. And then we have 1 minus 3 raised to the 4th power all over 1 minus 3. And let me plug that in the calculator. So there we go, all plugged in. Let me press enter. Negative 80. Okay. So negative 80, that goes with r. So we've got 7 is r. For this one, we're trying to find the sum for this series that goes from 1/9 to 9. So here's our sum formula. A sub 1, 1 minus r to the n, 1 minus r. We've got a1, 1/9. The common ratio, it looks like, is going to be 3. I have to keep multiplying by 3 to get from 1/9 to 1/3. The n value, though, we don't know how many terms there are. This is a short enough series that we could definitely write this out. I mean, the next term is 1, then 3, then 9. But if you wanted to do it kind of the long systematic way, let me show you another way of doing this. So we can use our a sub n formula to find the n value here. A sub n, we'll call that 9. And then a1 was 1/9. Our value is 3. We just established that because 3 times 1/9 is 1/3. And then we don't know the n value, so we'll leave that as n minus 1. So let me multiply both sides by 9 to get rid of this 1/9. So that's 81 over on the left side. And I can solve this equation by rewriting 81 as a power of 3. So this is really 3 to the 4th power. If 3 to the 4th equals 3 to the n minus 1, then that means that 4 equals n minus 1. You can basically cancel out the bases. And then adding 1 to both sides, we end up with 5 for n. Now I can go back and use my original sum formula. So I've got the sum of 5 terms. And again, our a1 is 1/9. We have 1 minus, this will be 3 for the r value. And we're raising that to the 5th power for n, all over 1 minus 3, and definitely going to go to the calculator for this. So this is where that fancy fraction mode is really helpful here. We have a fraction within a fraction. Let me press enter on all this. That comes out to 121 over 9. It simplifies it for me automatically. 121 over 9 is going to be choice A, so that's going to be 8 here. For number 9, we want the sum for this sequence of things. We have a negative 3 first term, r value 5, and then number of terms is 6. So let's look at our formula. a1, 1 minus r to the n over 1 minus r. We've got a1, we've got the r value, we've got the n value. That's actually everything we need for this formula. So we don't have to work too hard on this one. Just plug it in and chug it out. So we have the sum of 6 terms being negative 3, 1 minus 5 to the n power 6, all over 1 minus 5. And now let's let the calculator do the heavy lifting. Plugging all that in, we end up with negative 11,718. So that is going to be S right there. So that's 9. 9 is S. For the next one, we have some sigma notation. Now, if you actually do have a graphing calculator, you could plug this in directly to that. But we're going to assume that you don't, that you just have something that can calculate, but not necessarily to that extent. So how could we do this without just kind of cheating and using the sigma function? So let's use our sum formula. This is a geometric series. We can see that because we have this exponential term, repeated multiplication. So let me use my sum, a1, 1 minus r to the n, 1 minus r. And how many terms do we have? We're starting at index 1 and counting up to 5. That's a total of 5 for the total n value in this formula. So we have the sum of 5 terms. Our first term is going to be whatever you get when you plug this lower limit of summation into the formula here. Negative 3 to the 1 power is negative 3. And then we have 1 minus the r value of, well, we keep multiplying by negative 3 because that's what has this exponential n here. So this will be 1 minus negative 3. What power are we raising that to? There are 5 terms, so fifth power, all over 1 minus negative 3. And let's just plug that in the calculator. There we go. Let's press enter on all that, and that's going to be negative 183. 183 negative, that's O, so 10 is O. For the next couple problems, they're going to have us find the first term, given all this kind of stuff. So we have a summation of negative 364, r value negative 3, n of 6. We need to work backwards and find the first term based on this. So let me start with my sum formula. Sn equals a1, 1 minus r to the n, 1 minus r. So I've got Sn right here. It's negative 364. A1 I'm still looking for. We have 1 minus the r value, negative 3, raised to the n value 6, all over 1 minus negative 3. So let me simplify this a little bit. Let me get the calculator handy here. So on the right side, I've got, let's see here, 1 minus negative 3 exponent of 6. That comes out to negative 728. And then I've got this 1 minus negative 3, which is really just 1 plus 3, or 4, that I'm dividing by. I'm going to do that as well, so divide that by 4. That's negative 182. So I can write this as negative 182 a sub 1. Next, I'll just divide both sides by negative 182. Conveniently, that goes in twice to negative 364. So a1 on this one is 2, which is h, going in spot 11. For our final problem, we're still finding that first term given all this information. They actually gave us the same overall information, just in a different order. So here's my sum geometric formula. This time we have an Sn of 13,120. A1 is still the mystery variable here. We have 1 minus the r value 3 raised to the power of 8, all over 1 minus 3. Calculator time. So 1 minus 3 to the 8, I'll need the calculator for that. That is negative 6,560. I'm immediately going to divide that by, this is negative 2 down here, so divide by negative 2, comes out to 3280. And if I divide both sides by 3280, let's see what I get. So 13,120 divided by 3280, heavy lifting, thank you calculator. That comes out to 4, that's convenient. So we have a sub 1 is 4, which is actually n, and that goes in spot 12. At this point, we're ready to solve the puzzle. Again, the riddle was, what do you call spooky sausages? You call them Halloweeners. Ha ha, that's amazing. All right, until next time, Mr. Sutton signing off.